Wow, we got wicked shadows here. Let's see what we can
That's one thing I don't miss about those old monitors was the sun glare.
Oh yeah, yeah. Alright, that's doable. Cool, how's everybody doing?
Very good. How about yourself?
Pretty good. Saw a lot of late night submissions for PA2. So I haven't graded PA2 yet, obviously. I will probably get to it on Sunday. Today's a packing day, tomorrow's a moving day. So Sunday I'll get to it. Hopefully I'll get through them all on Sunday. If not, it might be a few days into next week. But you should probably be able to tell more or less what your grade's going to be on PA2 because you've got a sample executable. And as long as your code does what that sample does, you should be good. And you got some comments in there. Trying to figure out how Ruby works. Yeah, I have not done Ruby. But it's on my list of things that would be like, hey, if I had nothing to do, this would be really fun to jump into. But it always seems to be in high demand on job sites.
Yeah, is Ruby, is that kind of the object oriented?
I'm pretty sure it's object oriented, but it's I think it's like a back end thing also. Oh yeah, I remember your SLP proposal. You said you do web stuff, but you don't have Ruby background. Alright, so yeah, I also finally got through people's SLP proposals last night and posted your grades. So if you didn't get any feedback from me in the comments, you're good to go. The main comment that I gave people was regarding milestones. And for milestones, right, remember the milestones are there mainly for you to help track your progress. So you want to make sure that you have dates on your milestones so that you can track it, right? I'm going to get such and such done by October 31st. And then on October 31st, you can say, you know, oh, I'm behind schedule, I'm ahead schedule. And it can also help motivate you. If you say, you know, sometime in the middle of the term, I'm going to finish this, that's works really well with human procrastination, right? Where we say, you know, I'll get to this next week. So having that pinned down date is really helpful. Yeah, if you didn't turn it in or you turned in the wrong PDF file, definitely re-upload. All right, let's see. Yeah, anxiety helps sometimes, you know. You don't want to be paralyzed by it, but having a deadline is really helpful. And I mean, we all experienced this when I was in school, the realization that, you know, sometimes it's helpful to put a date on something. I got this with moving right now, right? I can't end my lease at my current place until October 31st, but this house came up and so we signed on the 9th. So I've got, you know, 3 weeks to move. What's the rush, right? Well, the danger is that, you know, 2 weeks from now I'll still be thinking, oh, I've got a whole week, you know, I don't have to do this. And that's where deadlines come up and hurt us in the end. So you know, I put down some dates in my mind and say, okay, so by Monday this is where I'm going to be, and so on. And this is you know, definitely helpful with the programming assignments as well, right? I mean, they're shorter term projects. They're usually a week, so you don't necessarily want to make, you know, a Gantt chart of milestones and all this business stuff. But giving yourself, you know, sort of sub goals with deadlines can be really helpful. You cannot generally do these programming assignments in a few hours. And in many cases, you cannot do them in one sitting. Even if that sitting was, you know, 12 hours long, you've got to be able to take breaks. And you've got to be able to change gears do something else, you know, with your mind, and then come back in order to see things that you know you're kind of blinded from because you were so close to it. If you're good enough at programming and have enough experience that you could do, you know, the whole assignment in an hour, I'm gonna say do it that first hour. You know, the first hour that you have free after the assignment's given, do it, be done with it, right? But if that's not you know how you view your programming abilities right now, piecemeal it out, right, and keep working on it throughout the week. And one, it stops you from, you know, the, oh, it's Thursday, I've got to do this by tomorrow, but I've got, you know, a physics exam coming up and I've got a lab due and all this other stuff, right? And it saves you from the situation where you think you know how you're going to do something, and then when you sit down to actually do it, you realize, oh, you know, this is different, right? And you want to make that discovery, you know, a week before, or, you know, 5 days before instead of a few hours before. And so at 8 o'clock I downloaded PA2s, and a third of them are not there. They're just, there's nothing there under PA2 on GitLab. And that worries me for two reasons. The first reason is, you know, if I don't have your assignment, I can't grade it. The other thing is, though, if there's not even, you know, a stick.c under PA2, it means that you've never pushed your stick project over to Git. And that's a really kind of dangerous way to go about these projects. So what can you do while you're working on your code? Git add, git commit, git push. 3 commands, right? Git add, git commit, git push. And you type those and your code's in the repository. And you do some more work on stick and you're done. Git add, git commit, git push. And you can write yourself a bash script. And what do you put in the bash script? $! bin bash. Git add, git commit, git push. And you can make yourself an alias like go. So when you say go, it runs your bash script, which does those 3 git commands. And now, you know, you're working on your code, you vi stick.c, you compile it, you fix some errors, you're good to go. Just type go, enter. And boom, it's over at Git. You work on it some more, type go, enter, and your new version is over at Git. And you know, you've got automatic backups. If your hard drive fails, if you accidentally delete your file, you've got backups of everything you've been doing, right? If every time that you get to a good stopping point, you just say go, you know, you've got a new backup of it. And then if something happens, if Thursday night you have to leave town in an emergency and you forget to bring your laptop and you can't get to internet, right? Well, the version you were working on Thursday afternoon, that's pushed over to Git, you know. And then if you tell me, you know, hey, an emergency came up, I had to leave town, I can go to Git and I can see where you were, you know. And that's a whole lot easier to work with as far as partial credit or, you know, an extension or something than just not having anything there. So you really want to get into that habit. And yeah, I mean, if you typo and you clobber your stick.c like someone just mentioned in chat, right? You've got all the versions, all the history of your work. I've also seen cases where this helped people with accusations of academic dishonesty, where there was code that was, you know, turned in identically by 2 students, and one of them had a single Git entry, which was made the morning of the assignment, and the other one had 2 weeks of Git logs, where they'd been making changes and pushing code in and stuff like that. And it made it really clear, you know, who had been actually developing the code for the 2 weeks that they had on this particular project, and who, you know, probably copied that code. So I mean, there's all kinds of benefits. All right, so send me an attendance note. Let me know that you're here. And attendance is dropping off in this section too, not as bad as the first section, but it's dropping.
forgetting, like less people are coming to class.
Seems like it, yeah. And not sure why that is.
C is the great divider.
Yeah.
Girl.
Yeah, it's funny. It's, you know, 120 we did Python, and then 120 we did C. And honestly, as far as like how hard they are to work on, I feel like once you understand the syntax, they're all pretty much the same. There's just different things to write. I mean, obviously they do different things and use them for different things, but I don't see C as any harder than Python or Bash or any of that other stuff. You just, once you kind of get into it, I feel like, you know, if you understand it, then it's just like any other language.
That's definitely true. There are a few jumps. Like assembly language is always really different to learn because it's so low level, you know. And if you've only done C or assembly language or Fortran or things like that, and you move to an object-oriented language like Python or Java, that's a conceptual leap. And there's odd languages like Snowball and Spitball and things like that, APL. But by and large, you know, once you know a few programming languages, learning a new language is not, you know, as big a deal as learning your first one or two or maybe three languages. Um, so,
Yeah, I have a friend that works for a biotech company that's a programmer,
mm-hmm,
and he said, honestly, he goes, you're not going to ever remember everything. Because
yeah,
I go on Google all the time and
oh
look
yeah,
up syntax for stuff.
mm-hmm,
But he goes, as long as you understand how a program flows and how like you understand the logic behind it, then you should have no problem actually developing that.
yeah,
Well,
that seems fair.
yeah, a lot of it too is like you get to where you're putting things into functions and then understanding. Yeah, I mean it's just making the leap between basic if then while loops and
Mm-hmm,
for loops and stuff, and then you get into functions, and then you have to understand what you can call into those functions. Because I had a lot of trouble making like a valid integer check
mm-hmm,
that would work with both taking in bash commands and taking in the user input if there wasn't already a bash command.
mm-hmm.
And I ended up having to do two different checks for that just because I was not satisfied with how it was turning out either way.
Right, right. Yeah, I think these are all
Would you
good
would you
observations.
just do that with like an argc? Would you could you make a function like that where it checks, you know, your argc and sees what it is and then does the logic in the function?
Yeah, in fact, we're going to do that today.
Oh, okay.
Yeah, I did call, I put a prototype and called a function within a function. I just didn't have it in me while I was working on the assignment to work out all the logic for a single, like, is valid check.
Mm-hmm. Cool.
Yeah, I did the function and a function for mine too.
And someone asked in chat, is it the same in 215? I'm not sure what that's referring to, because I don't know when that message came through.
He's talking about the drop off.
Oh, the attendance. No, 215 attendance I think is holding. But I think a lot of people were up late working on PA2. So that might be what's going on today.
Yeah, 215 is interesting. It's kind of a weird abstract concept, I think, for me.
It's a lot
It's
of,
kind of,
yeah.
yeah, it's entertaining to watch, you know, and understand that kind of stuff. So I got a quick question too, at the unrelated, not to go through the office hours for this, but I can't seem to use, because I have Xubuntu,
Okay.
and for some reason my VI, no matter what I do, does not work unless I log into the Linux server. So it still does the A, C, D, and all that, and I've tried to redo the file for that. I've gone through the steps like 6 times to do it.
So
when
so you tried downloading the EXRC file from the website? I think your audio was freaking out at the end there. There you go.
Yeah, sorry, I have terrible connection.
That's okay.
Yeah,
Did you try downloading
I tried.
EXRC?
Yeah.
Okay. Hop into office hours sometime next week, and we can play around with it.
Okay.
But I'm hoping next week to talk a little bit about VI, and different ways to use VI. And in particular, most students when they learn VI, they basically learn enough to use it like Notepad. You go into VI, you go into insert mode, you move around with the arrow keys, you type text, you backspace to delete, and maybe you copy and paste and cut with the mouse. And that's Notepad, right? That's Windows 3.1. You can do that, but it's not very efficient and it's not very fun. And it's not really how VI was intended to be used. VI is really intended to be used where you're staying in command mode almost all the time. And in command mode, right, you can move around with HJKL. And you only go into insert mode when you want to insert some text. And if you're staying command mode, then you can do searches, you can delete entire lines, you can copy sections of lines, you can move around by word or line or paragraph. You can jump forward and backward, you can jump to page to line numbers and all kinds of things. So I'm going to talk a little bit about that next week, and it may totally obviate the need for your arrow keys to work in insert mode at all, because there's far more efficient ways to move around than just going up, down, left, right, one character at a time. But yeah, if you hop into office hours, we'll see if we can get the setup file to work.
Alright, cool, thanks.
Yeah. Alright, yeah, someone said in chat they tried to make their PA2 code more expandable, and that's the direction we want to be moving in, is making our code, somewhat, we're writing a programming assignment, and that's our goal, right? But having a mindset of, kind of more generality than that will be useful, and it will actually let us think about ways that we can write our code more easily and get it working more quickly, as far as debugging and such. So let me talk a little bit more one last time about argc, argv, and scanf, because this was probably the main thing that people were running into when they were coming for help. Oh, cool. Okay. Yeah, someone just mentioned their aha moment with VI. Yeah, it was easier on me because when I learned VI, Windows didn't exist, and this was, a step up, because editing was usually done one line at a time, and you just typed in goofy things, and so there was no notepad to sort of fall back into that mindset with. But that's how a lot of people are sort of presented. How VI is presented to people is yeah, just do this and move around. Gedit is another editor that's usually available on Linux, and that one really is very much like Notepad, and it's got cut and paste commands and stuff like that. So yeah, we'll play with that next week. So let's play around with arguments. So let's write some test code. Alright, so here's my main program with the usual argc, argv arguments. And let's do some simple parsing. All right, so we're just going to take argv bracket 1. We're going to be doing command line option flags in C. You already know how to do them, actually. I mean, you can do them by hand. There's functions that are available to us to process command line arguments, but you can already do those with what you know, because you know how to tell how many things are on the command line with argc, and you can access them with argv. So, and you can use that to like add extra features to your code. All right, so remember the basic deal. We're going to run our program. I'm going to call it main, and if I say main space and I type a number after that, that number's characters will go into argv bracket 1, and when I do this sscanf, it'll convert it, store that integer value in num, and that should get printed out here. So let's compile this, and let's run it. And it says the number, you enter the number 23. And this works great. And you know, if you type in some weird number like that, you'll get some weird response back. That's okay. So in general, you know, my guideline has been if sscanf is okay with something, then we're okay with it. So I don't expect you to detect that the person typed in something bigger than 2 billion and handle it, right? But I expect you to use sscanf to know if this thing is an integer or not. So this works fine by itself, right? But it's got some issues. So the first issue is, you know, if you do this, it tells me, okay, you enter the number 32767. And that's not the number I entered at all. I entered the number, haha, which should tell me, hey, that's not a number. And I could check to see if, you know, the number is 32767 and yell at you, but sometimes it might be 32764. And, you know, I might actually say 32764, and I wouldn't want it to yell at me and say, that's not a number, because it is. So how are we going to know the difference between this and that? And the only way we can practically do that with sscanf is to check the return value from sscanf. So if you look at the man page for scanf, and you look at the return value, it says on success, these functions return the number of input items successfully matched and assigned. And what that means is, you know, what am I asking scanf to do here? I'm asking it to look at this string, see if you can match a bunch of characters in the beginning to be an integer, and if you can, store that integer value here. If that happens, it will return a value of 1, saying, hey, I assigned one value to one variable from one pattern that I matched. And if you type something like haha, and it doesn't look at it as being an integer, it will assign 0 things. And so the return value from scanf will be 0. So we can save this return value in a variable. So number of things matched equals sscanf.
So to determine whether it's an integer or not, is it breaking it down and like reading the ASCII code basically for that character? Mm-hmm. And if it's not between this and that, okay.
Yeah, and it's a hard task in general. So if you type 23, right? This is ASCII code 34. This is ASCII code 35. I'm doing that off the top of my head. It doesn't feel right. I think this is 50 and 51. But whatever, it's looking at the ASCII codes for these and it's saying, yep, that's an integer. Yep, that's an integer. I can put those together and get an integer. If I put a minus sign in the beginning, it sees the ASCII code for that, and it says, okay, that's good. But if I do 2 minus signs in the beginning, it's got to know, hey, I already saw a minus sign. That second minus sign is bogus. And it'll say, hey, that's not an integer. And for real numbers, it gets even more complex, because you can have decimal points, and you can have an e with an exponent after it, and the exponent can have a plus or minus sign, and it's a pretty complex task to try to take an arbitrary string and say, you know, is this a valid integer? And if so, what is its value? And this one function call does that for us. It gives us the integer value corresponding to that string, and it tells us whether or not it actually succeeded in doing that. So I can say if number of things matched is not equal to 1, I can say, hey, that's not a number. So if I say main followed by a number, that's fine. If I do main followed by something that's not a number, it'll say, hey, that's not a number. And of course, after that, it still told me that you entered the number, some ridiculous number, right? So what do I really want to do here? I probably want to say, you know, let's exit our function here. So we're starting to develop a parser for our command line. So let's keep going here. So the next problem is you know, if I do this, it says you entered the number 23. Well, I didn't enter 23. I entered 23, haha. And I'd really like it to tell me, hey, that's not an integer. So remember, scanf, what it does is it starts at the beginning of the string. And it looks at what it's trying to convert. %d says, I'm looking for an integer. So it looks at the 2 and it says, hey, you know, 2 could be part of an integer, so it remembers that 2. It moves to the next character, which is a 3. It says, oh, that's a 3 following a 2. That could be an integer. It moves to the next character, it sees an h. It says, oh, 23h, that's not an integer. But it saw a 23, and so it's going to say, hey, that looks good. It'll convert it to the integer value 23. It'll store that in the value of num, and it'll return a 1. Someone asked me that the other day too. No, you can't generally have an expression or an inequality in a case statement. In the switch statement itself, you can have any kind of expression that evaluates to basically an integer. It could be a character, which is a tiny int. But your cases in C, I believe they have to be specific values. But I could be wrong. There could be some extension that lets you do a range, maybe. All right, so this will return a 1 saying, hey, you know, I found one integer in here and I saved one value in num. But I want to know that, hey, there was some extra stuff over there, so we do this trick. Where is that coming from? Alright, that's just the ray of light and understanding or something. So we do this trick, which is we pretend that what we're trying to scan is not just an integer, but also some extra stuff after the integer. And we make an array that's, you know, big enough to hold a reasonable input line. And we say, you know, let's look for an integer, %d, followed by a string of characters, %s. And let's save the integer here and save the extra stuff after the integer here. And if we make an input line like 23 haha, and we have a %s here, and we have an extra, right? When it gets to the h, it will say that's not part of an integer. It'll put the 23 into num, but it'll look at the next pattern and say, hey, that h, that's part of a string, a %s. And so is the a and the h and the a, and so we'll take this ha and store that into extra. And now it'll return a 2 saying, hey, there were 2 variables that I wrote values into. And so we ask it to convert 2 things, but we hope it's only going to convert 1. We hope it's only going to find an integer and it's not going to find anything else. And if it does find anything else, then the return value would be 2, and we can use that to say, hey, something went wrong. So that works fine, and if we put extra stuff after it, it says, hey, that's not a number. And we can make this a little more specialized. So we could say if the number of things matched is less than 1, and if it's less than 1, it means that as it was scanning, it did not even find the beginning of an integer here. So scanf returned either a 0 saying nothing got stored, or a -1 saying the string was empty. So we can say if number of things matched is less than 1, let's print an error message. If the number of things matched is equal to 2, we can say so if number of things matched was 2, I'll print a message saying, hey, things started off looking good, but you had some extra stuff, and I'll go ahead and print out what that extra stuff was with a %s, just for kicks, and then I'll return. So main with a number works fine. Main with some extra stuff after it, it says, hey, it started off good, but you had some extra stuff, in this case a 0.5. Or, 23, haha. So we're getting pretty specific in parsing and understanding this argument that's been given to main.
If you declared a float, would it still take the 0.5 instead of an integer?
If you declared a float and you used a %g or something like that, then it would work. But if you try to get a %d and this is a float variable, you'll get a compiler warning, and the %d still wouldn't match the 0.5 part.
Okay, but if you use the right formatting and everything.
If you use the right formatting, yeah, you can definitely pick up a float like that.
Okay.
Yep. Yeah, and scanf is a real powerhouse function. It's like super powerful. All right, so this works pretty well so far, and of course we can do something like see if your number is in range. And let's suppose we wanted your number to be between 0 and 5. So if your number is smaller than 0 or bigger than 5, we can just print a message saying your number is out of range and return. Otherwise, we'll say, yeah, you entered a good number. So, for whatever reason, if you wanted to restrict your number, you could take the number 3, but if you did a number like 6, it would say out of range. So all of that works fine, right? And this is sort of the point that some people were at yesterday, and they were running into the following situation, which is if you just say main, you get a seg fault. And how do we know where the seg fault is coming from? put some print messages in. Right, so I'll say ready to do the sscanf, I'll do the sscanf, and then I'll say finished with the sscanf. So, you know, if everything works great, it does what it's supposed to do. But if I just say main, it says ready to do the sscanf, and then it says seg fault, and it never got to the finished with sscanf, and that tells me my seg fault happened right here. So that's the first thing, is can you pin down where the error happened? When we learn GDB, we'll have other ways to do this, but this is a quick way to locate where your error is happening. Just throw in some print statements. Alright, so why is this throwing a seg fault? We gotta go back to thinking about argc and argv. And if I say main 23, the way I access these arguments is through this argv array. And argv0 will contain main, argv1 will contain 2, 3. And when I say do an sscanf on argv bracket 1, I'm saying let's take this string, 2 followed by 3, convert it to an integer. But the issue, if I just say main, is that main goes into argv bracket 0. Argv bracket 1 doesn't have a value. In some sense, it does not exist. And what is my program trying to do? It's calling sscanf and it's saying, hey, take this thing that does not exist and see if it's got an integer followed by a string. And scanf has no idea how to work with something that's not there. And it throws a seg fault. Now it is there in some sense, but it's what we call null. It doesn't exist in a way that scanf can make use of it, right? And it's a pretty obvious issue that we're trying to convert argv bracket 1, but there is no argv bracket 1. In this case there is. And if they say main 23, haha, we've got an argv bracket 1. But if they just say main, there is no argv bracket 1. And anytime I try to do something with that, I'm going to get a seg fault. So before I try to do this statement, I have to do something to know, does argv bracket 1 exist? And you know, I might try doing something like calling string length on it and so on, but it doesn't exist. If I do string length argv bracket 1, that's going to generate a seg fault. So there's one way to know whether or not this thing exists, and that's to look at argc, and this is the reason that argc exists. If I say main 23, argc will be equal to 2. If I just say main, argc will be equal to 1. argc tells you how many things you have in this array. In this case I've got 2 things, in this case I've only got 1. So this is the case where I know I'm going to get into trouble. If argc is 1, I'm going to throw a seg fault. So once we know that, it's not too bad to try to deal with this. Right? We can do the following. If argc is equal to 1, then we can say, hey, you didn't specify an argument. And we can return. Alright, if argc is 1, then we have this case right here, where they said main, they didn't put in an argument. argv1 doesn't exist. If we go ahead and we try to scan, we'll seg fault. So in this case, we're just going to put an error message and exit. Now in the stick program, if they don't put an argument, then we have a dialogue with the user and we say, hey, how many sticks do you want to play with? And so on and so forth. But this is just looking at the parsing aspect. So you know, I can run this and it works great, and if I don't put in an argument, my code says you didn't specify an argument. And it returns quietly. If I don't do this return, then I still segfault. Even though I'm printing an error message, what does my code say to do after that? It says, go ahead and scan that thing that doesn't exist. And that generates a segfault. And if I do this, I still get a segfault. Why? Because I check to see if argc is equal to 1, but I don't check it until I get down to this part of my code. When I run my main program, remember it starts at the top of main after the first curly bracket. Declarations don't actually do anything at runtime. Blank lines don't do anything at runtime. So this is the first thing that's going to get executed. And it's a call to sscanf, and it tries to convert what? This thing that doesn't exist. And it gives a segfault. If my program lived long enough to get down here, it would print the message, hey, you didn't specify an argument. But it never gets here, because once it gets to this point, it generates an error and the program exits. So it's really important that I do this stuff before I try to use argv bracket 1. All right, so what if we want to make this cleaner? This is not even everything you needed for the beginning of PA2, because we're not dealing with the case where you put too many things on the command line, right? If argc is bigger than 2, we should throw an error. For example, if you say, main 23, 25, argc will be 3, we should detect that and say, hey, this is not valid because you specified an extra argument here. So we're not doing that, and we're not doing the dialogue where, the person didn't specify a command line argument, and we say, how many sticks do you want to play with? We get an answer, we parse it, and so on. So when all is done, this code would probably be more like 50 or 60 lines. And that's just to get started playing the stick game. Right? This is just pre-processing to decide how many sticks are we playing with. And if I've got, 50 or 60 lines of code before I even get down to, the main loop of taking turns and all of that stuff, right? This becomes a kind of nightmare to work with. So this is one way modularizing will help. So we could take this code and we could put it into a separate function and do something like this. Right? Let's just make a function called process that takes our command line arguments and tells us, how many, what number the user entered, and let's make a flag. If it returns -1, it means something went wrong. Otherwise, it means they typed in a valid number between 0 and 5, and just a valid number between 0 and 5, and this will tell us what that number was. Right, so now I've got this function called process, and let's have it return a -1 if anything goes wrong. So that's an error, that's an error, that's an error, that's an error, and if you enter a good number, let's return the number. And I'm going to prototype my function because we always want to do prototypes. right? So in any of these cases where I'm typing in something that's wrong, my result comes back as a -1. And in the case where I put in a valid integer between 0 and 5, my result comes back as that integer value. So what am I doing here? I'm packetizing all of this complexity into a nice little function call. And if I really want to bundle things up, I can put this in its own file. I can get rid of all of this. And now my whole stick program is 2 lines so far. And when I compile, I have to put these pieces together. Right? But this still works. And this is so much nicer to work with. Right? Number one, it's smaller to work with, it's easier to find things and so on. But more importantly, I can develop this by itself. I can say, I don't care about playing the stick game, I don't care about mod 4. I'm just working right now on a function that lets the user specify a number that's at least 20 for the stick game, or 0 to 5 for this case, right? And I'm just working on this code. And I can write a main program to test this, I can throw extra cases at it, and so on and so forth, I can tweak it. And once this is working, I don't have to think about it anymore. It's just something I call a process. Give it an argc argv, it gives me back a flag or a value. And if I want, maybe I don't want to print these messages in here, maybe what I want to do is return a different value for different things that go wrong. And then in my main program, I could do something like look at the result, and if it's -1, do something. If it's -3, do something else, and so on and so forth. So this is this idea of modularizing, right, that we started talking about the other day. This is thinking about how to take your large program and break it into pieces. So that we can develop those pieces individually and independently of other complex pieces, and B, just to make our code easier to look at, to work with, to debug, to maintain, and so on.
Now, if we do this for future projects, you just put it in, like, say, for the next PA3, will we just have everything in PA3 and that's how you would grade it?
Mm-hmm.
Basically what's in it? Okay.
Yeah, so you would want to make sure that in your repository you would have, in this case, main.c and process.c. And probably for PA3 we're probably going to do that in C, and we're going to talk about make files. And if you have a make file, then all I have to do is say make, and that'll go ahead and compile everything. And you'll create a make file that tells make how to build your executable. And then you're doing basically what people do when they distribute code, what they've done for decades, when they distribute source code that's meant to be compiled and turned into an executable. So that's a well-established process, and a good one that you'll want to know. All right, so last thing I want to mention is just there's this extra textbook that's mentioned in Canvas, additional C textbook, I think, that all the stuff we've been talking about with fgets and sscanf and so on is in this chapter 2, and it's a pretty fast read, right? It talks about what scanf does and what it doesn't do, and how if you use that in a loop you can get into trouble. You get this infinite loop, and how we get away from that by separating the input or ingest process from the parsing process. And so we ingest using fgets, and then we parse using sscanf. So these things we've been talking about in class, right? They're summarized in here. There's short snippets of code with explanations of what's going on and so forth. If you're looking for a different, approach to this, other than, going back and listening to me say something again and again on video, you know, by rewinding and trying to make sense. This is a different version of it, right? It's written out, and it was a slightly different presentation probably, and it may be useful. And in general, you may find this text useful as we go forward. When we start talking about pointers, there's 10 pages that summarize, you know, pointers. There's a couple of pages that talk about argc and argv, which could be useful. So take a look at this. I don't say read it cover to cover, because it's not that kind of book. But if you're having trouble with a particular topic, right, you might find some information in here. And some of this stuff is more for 222. We don't do recursion in 224, but in 222 we will. We won't do a lot of bit flipping in here, and we'll mostly do pointers in 222. But you know, it's a resource. It's free. It's there as a download from Canvas. If you're kind of stuck, this will be closer to what we've been doing in class than, say, Google, you know, or Stack Overflow or something like that, where you will find answers, but you'll find so many answers, and you know, maybe a small set of them will relate to what we've been doing, but it may cause more confusion. So just wanted to mention that as another resource. All right, send me an attendance ping on the way out. Let me know you're still here. That should do us for today. So if you're in 2:15, I'll see you in a half hour. If not, have a great weekend, and I will see you on Monday.